over bonding. And just to kind of refresh our memory for bonding, how many valence electrons can you have on that outside shell? 8. You can only have 8 dots. Now remember that those dots have to be, you need to go around once before you can go around again, okay? And that's because you're going to leave space for the bonding. These two can bond somewhere else, okay? And actually every bond is going to have an electron on one side along with another electron on the other side. So let's look at hydrogen first. Hydrogen has how many valence electrons? Look at your periodic table. Remember, you're counting your S's and your P's. So how many dots? It's going to have 1. Okay. Now oxygen has how many? Boys, we need to be concentrating, okay? It's okay. Leave them alone. Okay. Now oxygen is going to have how many? 6. Okay, so 1, 2, 3, 4, 5, 6. Now I'm leaving the empty spaces on this side because my hydrogen is on this side. It's going to be easier for the bonding, okay? Now, before we actually do the bond, you need to know if it's an ionic bond or is it a covalent bond. Mijo, we need to put the phone away and we need to unplug completely. Okay. Hydrogen, is it a metal? Is it a metalloid or is it a non-metal? What is it? It's a non-metal. So it's a non-metal. Now what about oxygen? Is that a metalloid or non-metal? It's a non-metal. Guys, we need to be unplugged, okay? It's not going to take longer than 10, 15 minutes. Not even. Unless you guys want more examples. Okay, when you have two nonmetals coming together, that's a covalent bond. Okay? When you have a covalent bond, and this is from yesterday's notes, the electrons are going to share. Miha, can you do me a favor? Can you close the door, please? Thank you, sweetie. Okay, these are going to share. So now, one's going to be the giver, and the other one's going to be the taker. So look at your charges that are on top of the periodic table. What's my charge for hydrogen? Yep, it's a +1. What about oxygen? What's my charge? Of -2. Very good. So your cation is going to actually lose that electron, because remember your plus charges lose the electron. My negative charge is going to what?
Miss, where'd you get -2?
Yeah, where'd you get the -2?
I gave these to you on the notes last week. I put the periodic table up there, and you have +1, +2, +3, plus or minus 4, -3, -2, -1. It's very important that you put those charges up there. We're going to be using them for the next month and a half. Okay, actually, you're going to be using it for the rest of chemistry. Okay, that periodic table is going to give you that charge. Okay, so now, here, because they share, the hydrogen is going to be the one that loses. So this valence electron is going to go to the oxygen, and it's going to share with the oxygen. Did it give away all of its dots? Yes. There aren't any more to give away, right? Oxygen now, instead of having 6, has how many? 7. Now, is it in that happy state? Nope. It needs how many more electrons? It needs 1 more. Very good. To be at that happy state. Because you want it to be stable, right? And so here there's an empty space here. So what can we add? Another hydrogen. And hydrogen has 1 dot. So this electron's going to share with that empty space. And now, did this hydrogen give away all of its dots? Yes. Does oxygen have all 8? Yes. So now they're both happy. Your bonding is ended. So your chemical formula, it took 2 H's to fulfill that oxygen. And so now it's stable, and your chemical formula is H2O. That's chemical bonding. And that's it. That's how your elements come together. Now, you can also break it apart, right? Yes? What's your question?
Never mind.
No, ask it. Are you sure?
No, yes, I just figured it out right now.
Okay, H2O is water. And almost anything that like even the elements that we did on that last lab, the flame test, when you're testing that, ever see that smoke that's coming up? You have water vapor in there. So anytime that H2O can come together, hydrogen is very reactive. It only has one electron. So anytime, it's always looking for someone to bond with, whether it's going to share or give away that electron. That's why it's so explosive. It's so reactive because it only has that one electron. It's willing to share with anybody, even itself. That's how it becomes a diatomic molecule. Okay? Now, to break water apart is a lot harder. Okay, it's a lot easier to make water than it is to break it apart. Okay, so you have to use something like electrolysis to actually separate it. And so you can put hydrogen gas in one tube, oxygen gas in another tube. That's called electrolysis. Now, of course, you don't want to accidentally set the tubes on fire. I mean, they're both explosive, right? Okay, but you can separate it because it's a compound. You can separate it into two different elements. Okay, but this is bonding. Now, tomorrow you're going to have to identify whether it's a covalent or an ionic bond. Let's do another one. Let's do an ionic bond. Okay, so let's do something that's not on your sheet. Like, let's do potassium. How many valence electrons does potassium have? It has one. Very good. Okay. How many valence electrons does bromine have? Very good. It has 7. So you have 1, 2, 3, 4, 5, 6, 7. Okay, so here we have an empty space. And I left that there on that side on purpose so it'd be easier to bond, okay? Now, potassium, is it a metal? Is it a metalloid or is it a non-metal? It's a metal. Very good. Now, is bromine a metal, a metalloid, or a non-metal? It's a non-metal. Very good. So when you have a metal and a non-metal, what kind of bond does that give you? That was in the notes yesterday.
Is it
Ionic. It's an ionic bond. Very good. Okay. So now that ionic bond is going to be different from the covalent bonds. Is going to transfer those electrons. Okay? So now, is it easier for potassium to gain 7 electrons or to give away that 1 electron? And so it's going to transfer that 1 electron. Now, what's your charge for potassium? It's a +1. Very good. And what's your charge for bromine? Or bromide? It's a -1. So this one is missing 1 electron. It's going to gain 1. And potassium is actually going to lose 1. Okay? So now, this is going to transfer right into that empty space. Okay? So now, did potassium give away all of its dots? Yes, so it's happy. Does bromine now have all 8? Yes. Okay, so now it's happy. It's at a stable state. So remember that one's going to be the giver, the other one's going to be the taker. Okay? So now, how many did it take? How many elements of each did it take to make this bond? Yep, so you have 1 potassium and you have 1 bromine. This is your chemical bond. Okay? Now, someone asked me in 4th period, ma'am, how do you know which one goes first and which one goes last? Like, could you have something like BRK? No, you can't. The positive charge is going to be on the left. The negative, the anion, is going to be on the right. Okay, always. Okay?
You have 2 negative charges.
You can, but that's going to be a covalent bond.
So it doesn't matter.
So you could have like a carbon and an oxygen, and that's a covalent bond. It matters on who's sharing with who. I'll show that to you guys in a minute. Okay? All right. So do we have any questions so far? Where do we have a question?
Why is it ionic again?
Ionic because this one's a metal and this one's a non-metal. Whenever you have a metal and a non-metal, that's an ionic bond. Whenever you have a non-metal and a non-metal, that's going to be a covalent bond. Yes? That's the notes I gave you last week on the periodic table on the very top. Okay, so we went from left to right. And on the top part, hydrogen, that whole first group is a +1. The earth metals is a +2, like that. It's on last week's notes. Okay, and I asked you guys to put that on your periodic table. I would also leave that on your periodic table because you can use that for the tests, for the semester exam and for the final exam. Okay? All right, let's do one that's not so easy. Let's do something that's a little longer, a little harder, that's not on your assignment. Let's do like, let's do calcium. That has a +2. And let's do antimony, SB. Okay, which is a -3. All right, so how many valence electrons does calcium have? Yep, it's coming right off your charge, and it's the second group, right? Okay, how many valence electrons does antimony have? Bless you.
5.
Yep, 5. Very good. So you have 1, 2, 3, 4, and 5. I'm going to put that up here. Okay, so I have an empty space here. I have an empty space here. And I have an empty space here. Okay, so now, what kind of bond is this? Is it ionic or is it covalent? Yes, it's going to function like an ionic bond. I know antimony is near your metalloids, but it's going to function like, kind of like a nonmetal there. Okay, so we're going to transfer from calcium to that empty space. And then we're going to transfer this second dot over here to this empty space. Is calcium happy?
No.
Did calcium give away all of its dots? Yes, so calcium's happy, okay, because it shared all of its dots. Now, is antimony happy? No, because we have an empty space right here, right? Okay, so we need to add another calcium. And so here's one valence electron, another one right here. So this one's going to transfer into that empty space. Now is antimony happy? Yes, it has all 8, correct? Okay, but is calcium happy? Nope, because it hasn't given away all of its dots. And its need in life is to actually either transfer or share all of its electrons. Okay, so now you're going to go to antimony. And you're going to have another one. So 1, 2, 3, 4. Let's put 5 here. Okay, so I have an empty space here. This dot's going to transfer into that empty space. Now is calcium happy? Yes, but who's unhappy? The antimony. Okay, so that antimony, I need another calcium. And I have 2 dots again for calcium. So now, this dot's going to transfer into this empty space, and this dot, okay, Meha, go ahead and go, is going to go into this empty space. So is antimony happy? Yes. Is calcium happy? Yes. So now I've given away all of the electrons that are floating around, and all of the empty spaces have taken up, they have the 8. Like antimony has all 8, and antimony has all 8 on this one. And on this one. Okay, so now, how many calciums did it take for us to finally be stable? It took 3. So we have 3 calciums. Very good. How many antimonies do we have? 2. This is my chemical bond. Okay? Where are we lost? Where do we have a question? How do I know if it's an ionic bond? If it's a metal and a non-metal. I knew I heard it here somewhere. Okay. Now, how do I know if it's a covalent bond? If I have 2 nonmetals, not just 2 of the same, because I can have 2 metals, but that'll be a metallic bond. Okay? So covalent has to be a nonmetal and a nonmetal. Okay?
Are there,
Not on this one.
not on this one?
Not on this one. Okay.
Ionic?
Okay, I'm sorry. Which question?
Does this one
Yes, you can tell me whether it's covalent or ionic, okay? But we're going to do that tomorrow. We're going to actually label them, okay? All right, but do put the chemical formula. Now, I did have a question earlier today. Ma'am, if, like, number 1 is sodium and chlorine, I know that I only need one of each. Can I just put NaCl? No, you have to show me the bonding, why it goes together, okay? We got it? All right, if you want to, you can choose one from the assignment and we can do it together. Boys, if you're already ready and you don't need any more examples, then go ahead and get started. Do we need to do one together? You want to pick one from your assignment? Okay, pick one. Tell me which one. Number 6. Number 6 is magnesium and nitrogen. Okay, so how many valence electrons does magnesium have? On my desk, Mihan, thank you. It has 2, very good. How many valence electrons does nitrogen have?
Oh, it has.
It has? Austin, pay attention, mijo, and you should be doing this along with us. Okay. How many dots does nitrogen have? 5. Very good. 1, 2, 3, 4. And let's leave that up here, 5. Okay, so I have an empty space here. Now, is this an ionic or covalent? Am I going to share or am I going to transfer? Covalent has to be non-metal and non-metal. So it's ionic because I have a metal here. This is a metal. Oh, why isn't it writing there? Okay, and this one's a non-metal. Okay, so that's an ionic bond. So they're going to transfer. So I'm going to have this valence electron is going to transfer that empty space. And then this valence electron is going to transfer to this empty space. Okay, is magnesium happy? Yep. Are we done? Nope, because we still have an empty space on this side, right? So what do we need? Yep, very good. You need another magnesium. And so I'm going to have another 2 valence electrons. This one's going to go to this empty space. And so now is nitrogen happy? Yes, it's 8 valence electrons, right? Okay, but is magnesium happy? No. So I have to add another nitrogen. Very good.
Is it wrong if we don't put the charges on the elements like when we're writing it out?
No, if you don't put the charges, you still have to do the correct valence number, though. Okay? I put the charges there so you could see why, how many you're losing and how many you're gaining. Okay? Because with magnesium, because it's a +2, that's why you're losing 2. Okay? And with nitrogen, because it's a -3, that's why you're gaining 3. Okay? All right, so what do I do here? Yep, this one's going to go into an empty space. Very good. So now is magnesium happy? Yes. Am I finished? No, because I still have 2 empty spaces with nitrogen, right? So I'm going to add what? Yep, I'm going to add magnesium. Very good. And I have 2 valence electrons. So this one will transfer into this empty space, and this one will transfer to this empty space. Now is nitrogen happy? Yes. Is magnesium, has it fulfilled its job? Yes. Okay, so now it's balanced. How many magnesiums did it take? And how many nitrogens? Yep. This is my chemical formula. That's my bond. Okay? Are we all good?
Yes.
Or are we not good? Remember, your whole objective is that one of them is going to lose all of its electrons. The other one's going to gain up to 8 electrons. I mean, it's not going to gain all 8. It's going to have some and it's going to gain a few, right? But you're going to make all 8. So one's going to be the giver, one's going to be the taker. Yes? Until it's all completely balanced. Okay? No questions? We sure? Okay, all right, you're gonna do both sides of that worksheet. Okay, don't forget to make sure that the bonds